this is when we're using our a squared plus b squared equals c squared. Remember, c is always the biggest side, the largest side. Or if you want to look at it, you can, a and b are your legs. It's going to equal to the hypotenuse. C is your hypotenuse squared. So make sure you know the parts. The hypotenuse is always opposite the right angle. Okay. Now, this is the part I want to make sure we understand. It says right here, use exact values. When it wants an exact answer, that means no decimals, meaning no rounding. So you're going to give me the simplified radical answer when I ask for an exact value. So, so you're going to have only one question with the sides as whole number. So like on a problem like this, 22, if I look opposite this right angle, the C would be the X. So 5 and 15 would be our B, A and B. So we're going to use the Pythagorean theorem, which states a squared plus b squared equals c squared. So we have 5 squared plus 15 squared equals x squared. And a horn over there. So 5 squared is our 25. 15 squared is our 225 equals x squared. So we get 250, right? So don't forget, I'm going to come over here, sorry, that you have to take the square root of that. So this is when you have to simplify this. 25 times 10 gives me 250, so this would end up being 5 root 10 equals our x. Yeah, okay. So, Pythagorean theorem, you'll have one with just regular whole number sides. Maybe find the leg or find the hypotenuse. I think it's 1 or 2. It might be 2 now that I think about it. But you're definitely going to have a problem like 25 where you have to use understanding what happens when you square a radical. So in a situation like this, this is my leg right here, this is my leg, and this is the hypotenuse. It's missing the right angle. Okay. Yeah, that should have been there. All right, so this, when I work this out, I'm doing my m squared plus my 15 squared equals the hypotenuse. So that, put this in parentheses, 3 root 34 squared. And we have to remember, anytime I square a number, it's always going to be positive, but if I square a radical, it's always going to turn into what? A whole number, okay? So just make sure you remember to do that on the calculator correctly. Use your parentheses and make sure you arrow to the side. So like if I'm doing 3 and then second, do my radical, it was what, 34. Arrow to the right to close that parenthesis, and then you can square it. Okay, we got 306. So we have basically m squared plus 225 equals 306. And then I'm going to have to subtract the 225. So my m squared equals, did I do that right? Yeah. Why am I, okay, sorry. Oh, no, take your square root. That's what I forgot. Take your square root at the end. This is a perfect square. Yeah, 9 is our answer. Okay. On a problem like 27 here, we have an equilateral triangle. You got to remember what that means. Okay, it means all the sides are congruent. So if I know this is 24, then DE is 24 and DF is 24. Now they want you to use the altitude here, this X. When I draw that, it's perpendicular and it creates the right triangle inside. Okay, so now I can use Pythagorean theorem because that altitude, that height of that equilateral triangle bisects the base. So this is going to end up being 12 and 12. So if I'm just focusing on the right triangle on the right, it doesn't have to be the scale, but basically the hypotenuse is 24. One of the legs is 12. We're trying to find the other leg, which is X. So using Pythagorean theorem for that. So your X squared plus 12 squared is going to equal to 24 squared. What's our 24 squared? Is that 624? 576. I'm off. All right, so taking this 576, and then we're subtracting the 144. What's the 432? Okay, oh, there it goes. Then we're going to take the square root. Don't think that's perfect. So I need to find a perfect square. It goes to 432. We need to simplify this. That's 4, 7, 8, 9. So just 36 work. I think there's one bigger than 36. What was it? Is it yeah, there we go. Yeah, 36 would work, but I would have to simplify the 12 more. So 144 and 3. 144 times 3. The 144 is the perfect square that comes out. So X is 12 root 3. Okay. So you're going to have a couple questions just finding the missing sides of a right triangle. And then I'm going to actually use the converse of the Pythagorean theorem. So we go to this next page. Oh, before the second section, right here, word problems in the converse, I want to talk about, we did one with the radical, so I'm not worried about that. But I'm talking about 30 real quick. If you have adjacent triangles, you need to start with the triangle that you at least have two sides with. So I would do this triangle first because I have the hypotenuse and I have a leg. So what's missing is this leg here. I'm just going to label that Y. I'm going to just give it a different variable than X. So I want to find the Y first, use this triangle first. That means I'm doing 5 squared plus Y squared equals 10 squared. So use the triangle you have two sides for first. So this is what, 25 plus Y squared equals 100. Subtract the 25. Your Y squared equals 75. And then take the square root. This simplifies to 5 root 3. Okay. So that's the shared side, which I'm going to put right here, 5, oops, now you can't see it. This is our 5 root 3. And then this triangle, that is the hypotenuse as well. 4 would be your leg, X would be your leg, so you're doing 4 squared plus X squared equals the 5 root 3 squared. So 16 plus x squared equals 75. Then you're subtracting 16 on both sides. You get x squared equals 559. And then we're taking the square root, and that cannot be simplified. So just x equals the root 59. So if you can't break it down, there's not a perfect square that goes into that, because I think it's prime. So just leave it like that, okay? With the Pythagorean theorem, you are gonna use right triangles with word problems to find missing sides. All right, so on 31 here, we got Westfall 7 miles south of Edenville, and Concord is 13 miles west of Westfall. What is the distance from Eden to Concord, round to the nearest? Okay, so in this one, because this is round to the nearest tenth of a mile, you're going to give me the decimal answer. And it says head draw picture. So because we're talking about north, south, okay, north, south, west, and east, okay, like on a compass. All right, so I'm just gonna try to create a right triangle here. Anytime I'm dealing with Pythagorean theorem, I have to draw. I'm using right triangles. So from Eden to Westfield, 7 miles south. So I'm just gonna do E for Edenville. If I go down south, I end up in Westfield. W for Westfield, and that was 7 miles. Then it says Concord right here is 13 miles west of Westfield. So if I go this way, oops, that's crooked, but west is this way. That's 13. There's Concord. They want us to find the distance from Edenville to Concord. So that means going this way. That's what we're trying to find. So I'm going to make that an X. I don't know if you kind of see now, there's a right triangle here. All right, so what we're trying to find is the hypotenuse in that right triangle. So you're just doing 7 squared plus 13 squared equals your x squared. And you're going to get a decimal answer. Okay. And just take your square root. So because it says to the nearest tenth, that's one decimal place. If I do second x squared, 218. We're going to do 14.8. Okay. So the thing is to use the converse on the Pythagorean theorem on this section, they want you to first determine if it's a triangle. And basically, you're going to have 3 sides. We always want to compare it to the longest side. But to determine if it's a triangle, C, which is our longest side, excuse me, our other two, A plus B, has to be greater than C. When that happens, when we're just adding the 2 short and compare it to the largest, this makes a triangle. Now, the converse is, once I have a triangle, I'm going to compare the largest side, and if I square that side and it is greater than a squared plus b squared, then that proves it's an obtuse triangle. Also, if I compare that largest side, c squared, and it's less than the a squared plus b squared, then it's a acute triangle. And if c squared equals a squared plus b squared, and it's a right triangle. So you do need to check that it is a triangle first and then compare the squared lengths, okay? So like here on 33, I look for my largest number, which is the 25, and then I compare the other two. So I'm adding these two, 11 and 13 is 24. 24 is not greater than 25, so this is not a triangle. Versus when I do like problem 34 here, again, 19 is my C, okay? 9 and 15, when I add those, that's going to be bigger than C. So I already know, yes, it's a triangle. So now I need to compare the square lengths. I'm doing 19, oops, sorry. I'm doing 19 squared, and I'm comparing it to 9 squared plus 15 squared. Okay, so if you want on the calculator, just do the hypotenuse squared and then do your sides, the sum. Okay, so I got 360 compared to 306. Okay, 361, excuse me, is greater than 306. So when it's greater than, it's obtuse. Okay. So that pretty much covers all of Pythagorean theorem. You are going to be able to use that with the last section or with the last two sections for distance and midpoint formula.